So go back and launch the tool which we had yesterday, which was the Weka tool. I hope we can launch it. So we have a screen which comes like this. So we have a screen which actually shows 4 different applications. So at this point, we actually launch the Explorer. So I hope all of you can open this. Then what we do is we open a file. Let us open, say, the file in your directory inside Weka. So of course we have here in a different directory, but inside your Weka folder, you will probably have a data directory. In that, you will see that there is a file called supermarket. So if you see supermarket, you see that there is a lot of items being purchased in a supermarket, and you have a lot of data. We have 4,500 data items, which is a set of transactions, which actually is a set of items bought in each transaction. And then we can do multiple things here. We can either take variable, let's take, say, glossary miscellaneous, and then we can see how you can visualize for that particular item. Let's take, for example, you're talking about grocery item. Then you can see that there are 178 different, items which have non-zero kind of entries for grocery miscellaneous. Similarly, you can do other elements related to each data item. But what is most important for us is we want to do a association rule mining. So click on the associate. Then we have a default algorithm here, which talks about Apriori algorithm to be used. So click on that Apriori link here, convert number of rules to what you want. Let's talk about 20 rules. Then we can say that even confidence, if you want 90%, or if you want, say, 0.85 as a confidence. Then you say OK, then run it. So what it does is this basically is going through the whole set of transactions and running the Apriori algorithm, first the item sets, and then converting them to the association rules you're finding. So here you're seeing that we have only output the top 20 rules because you wanted that, and you're seeing that only ones which have confidence of above 0.7 is what you have displayed as the output. So this is something which is at the foundation of what we call as the market basket analysis, which is very popular in context of e-commerce or retail, in terms of understanding what items people are purchasing. So here, when we talk about doing this, let's go back to repos. And then when you do the association, right, you can see that the output is generated here and the set of rules are in. But there is this notion of being able to customize your requirement for running your algorithm depending upon how you want to get your results. So that is where this tool enables you to do it. But I wanted to mention to you that if you are more in Java, all of these are available as classes, and you can write your own Java program with APIs for the Apriori function and pass it into your program, and then that can feed into your knowledge, the kind of program you're writing, which is part of a larger. It's possible to embed as a Java class file inside your program, and then you can embed Apriori as an algorithm with the inputs as part of your process itself. If you're more keen on program, need not be dependent only on this command line and visual interface which Weka is providing you. Similarly, let us look at another important element we saw yesterday, which was about the unsupervised k-means clustering. So let's open the iris data. So what are we doing here? We're trying to create pattern of the clusters among the data which are unlabeled. So here, though this is basically representing something for a classification, what we can do is go clustering, and then we can say that we can ignore specific attributes. So we want to ignore this attribute called class. Then we start with choosing the algorithm. The clustering algorithm, there are several examples, so we're choosing simple k-means here, right? Simple k-means, again here, number of clusters is something you may want to change or you may want to experiment with. So say, let's say we're talking about 3 clusters. Then run it. So this gives you a model of clustering of the whole data into 3 separate clusters. So we find that 61 of them are going to cluster 0, 50 of them are going to cluster 1, and 39 are going to cluster 2. So this actually is basically one of the ways by which you can see the whole thing in a visualization. Imagine here we're talking about 4 different variables, and we are talking about 4 different variables means we're talking about a 4-dimensional plane. So to visualize what is possible, you can visualize each binary variables. So you want to visualize a petal with something like a petal length. So what does that petal length with petal width give you? It gives you a visual representation of the corresponding cluster. So what we find here is that while the clusters are found from pairwise comparison, it actually is a multi-dimensional element which is having 4 different dimensions. Now the question comes, you created this model, you created this clustering algorithm. If you want to use the same algorithm for a future data, that's where we want to show you that go to the run you have done here, and you can go and right click and you can save the model. When you save, what it does is it gives you a way by which you can save the algorithm which you have used and the clusters that have been obtained and the equations thereof in sorry, I think I should choose a directory which is you can save the model. Say in desktop I can save it. I'd say trial1.model. So what happens is, if you want to choose for a different invocation where you have new data that has come in and you want to use the algorithm that has kind of been used in the past, you can load that model and you can run that model again on the fresh data. You understood? So this is the equation which you have derived, or the graph you have created or the cluster boundaries which you have created using the k-means is basically now that model which you have generated. This will be more useful when we're talking about supervised learning as well. Important thing for you to understand is this notion that what you have run once, you want to reuse that model for a future data is a very important thing, especially when you want to create a reusable model for future data. So this is something doing with respect to how you can visualize one kind of variable with the other. On the X side, you can take any variable, you can plot it along with the Y variable. But here, one thing got to understand is the visualization of a 4-dimensional variable here is pretty complex. That is why we take the easier route of how you can transform them into binary comparison of dimensions and start visualizing. So this is basically what was giving you this idea of having 3 separate clusters. Whereas there are other algorithms which you can look at here. If you go over each of these algorithms, you will find the description corresponding to it. So I already do about hierarchical clustering, where you start initially with a K cluster, then you try to divide each cluster which you have obtained and further divide the big cluster into smaller clusters by running k-means within that cluster again. So that becomes a hierarchical cluster. Same way, there's another example as expectation maximization, which basically is an alternative which is dependent upon probability distributions of the data, and using the probability distributions and concepts like Mahalanobis distance, which is basically a statistical variant of Euclidean distance between any 2 points in the hyperplanes. That gives you another way by which you can find out groups of related data items which form individual clusters. So that's why if you see Weka as a tool, it gives a great way by which you can read about each algorithm and then experiment them on individual data items. So that is where we had done till now. So till now we saw that Weka as a tool is able to help you with multiple algorithms. We've seen association rule algorithms, we've seen clustering algorithms. It can allow you to also visualize data as it comes in as output. It also allows you, like we saw today, the generated out can be stored as a model for use for the future data by loading the model which you have saved already. So that is the power of this kind of a tool, where you don't have to always necessarily run everything from scratch. Yet another point which I mentioned, which is something available on the site of Weka, which is an entire API of all these problems, whether it is simple k-means or a priori. All of them are available as classes which you can use in your own Java program. And then you can write a more comprehensive Java program in order for you to embed these machine learning algorithms in order for you